So in the last class, we went over 13 problems, first 13 problems. So in today's class, we'll try to go over the rest of the problems. So number 14. So this is from chapter 7. So suppose that a random sample of 50 bottles of a particular brand of cough syrup is selected and the alcohol content of each bottle is determined. And mu denote the population mean or average alcohol content. And we have the 95% confidence interval. And the confidence interval is from 7.1 to 9.5. So now the first question is, would a 90% confidence interval calculated from the sample have been narrower or wider than the given interval? Explain your reason. So what do you think? Which one is the correct answer? Do you think that it will be narrower or wider? So instead of 95% confidence interval, if we construct 90% confidence interval, then the interval will be wider or narrower? Yeah, it will be narrower because we are reducing the confidence level. So it will increase the precision. So that's mean the interval will be narrower. Yeah, you are right. Thank you. So why the interval will become narrower? Because the critical value, the first option is the 90% would be narrower since the critical value of 90% is smaller than the critical value for 95%. So for 90% confidence interval, the critical value will be smaller than the 95% confidence interval. So that's mean the margin of error will be smaller. So that's why we'll have a narrower confidence interval. So part B, consider the following statement. There is a 95% chance that mu is between 7.1 to 9.5. Is this statement a correct statement? What do you think? Yes, I have started the recording. Yeah, I can send the Zoom link. I can post the Zoom link on Blackboard, or maybe I can email it again. Okay, I can forward the email again. Give me 1 minute. Okay, so I'm sorry for the inconvenience. Okay. So the part B is consider the following statement. There is a 90%, 95% chance that mu is between 7.1 to 9.5. So do you think that this is a correct statement? So this is not a correct statement because mu is always fixed. So there is nothing about probability of mu. So because mu is fixed. So that's why this statement is not correct. So I already told you that when you will be interpreting the confidence interval, you should be very careful. Do not say anything about the chance of mu being in the interval, but instead of saying that, you should say we are confident. We are 95% confident that the interval will cover the mean, or the mean will be okay. So here the first one is it is not a correct statement. Yeah, that part is correct, but how about the second part? There is a 5%. No, this is not correct. So first one is not correct, but second one, it is not a correct statement. This is true, and we are 95% confident in general procedure for creating the interval, but the mean may or may not be enclosed in the interval. So we do not know if you create a confidence interval, you do not know whether the mu is in the interval or not. And third option is it is a correct statement, so this is not true. Fourth option is it is not a correct statement. This is true, but each interval contains the mean by definition. No, this is not true. And last one is it is a correct statement. This is not true. There is only no. This is also not true. So the correct answer is B. So for B, the correct answer is the second option. For part C, consider the following statement. We can be highly confident that 95% of all bottles of this type of cough syrup have an alcohol content that is between 7.1 to 9.5. Is this a correct statement? No, it is not a correct statement because the confidence interval doesn't mean actually this statement. It means the interval is an estimate for the population mean, not a boundary for the population values, because the boundary for the population values is the prediction interval, not the confidence interval. Confidence interval is the boundary for the population mean. So that's why the correct answer will be option C, third option, sorry. So for part C, consider the following statement. If the process of selecting a sample of size 50 and then computing the corresponding 95% interval is repeated 100 times, so that's mean if the sample size is 50 and if you repeat the confidence interval, constructing confidence interval 100 times, then 95 of the resulting intervals will include mu. So is this a correct statement? No, this is not a correct statement. The confidence interval means if you construct 100 confidence interval, then 95 of the confidence interval, there is a chance that, or we expect that 95 of the confidence interval will include mu, but there is no guarantee. So that's why we cannot say that 95 of the resulting intervals will include mu. But there we expect that. That's our expectation. But this doesn't confirm that 95 of the interval will include mu. So that's why it is not a correct statement. So the correct answer will be we expect 95 out of 100 intervals will contain the mean, but we do not know this to be true, but we do not know whether this is true or not, but we expect that. Do you have any question? Okay, so problem 15, a random sample of size n is equals to 15 heat pumps of a certain type yielded the following observations on lifetime in years. So here are the lifetimes of 15 heat pumps in years. And part A is assume that the lifetime distribution is exponential. So we are assuming the distribution is exponential distribution. Okay, so uh, actually I should skip this question because usually we didn't construct confidence interval for the exponential distribution. So in class we discussed about the small sample with normality assumption and the large sample without any assumption. So actually we should skip this question. So for exam, You do not need to solve problem number 15. Okay, so number 16 is determine the confidence level of each of the following large sample one-sided confidence bound. So the assumption is large sample assumption. So that's mean what type of distribution we can use to find the critical value. So should I use normal distribution or t distribution? So here the assumption is the sample size is large. So what do you think? Yes, we can still use the normal distribution, right? We can use we can still use the z interval. Yeah. So because here the sigma is unknown. So when sigma is unknown, we have to look at the sample size. If the sample size is large, then we'll use z interval. Otherwise, we'll use t interval. So z interval is z. So this is one-sided. So one-sided upper bound. So what is the critical value for one-sided upper bound? So z alpha or z alpha over 2? Which one is the critical value for one-sided? This one or this one? So this is 1, this is number 2. So which one we should use? 1 or 2? Yes, we should use z alpha. Yeah, you're right. Because this is one-sided confidence interval. But if we have two-sided, then you have to use z alpha over 2. And for lower bound, negative z alpha over 2. But this is one-sided, so confidence level for one-sided confidence bound. So that's mean you have to use z alpha. So you do not need to use this one. And for this one, you will also use z alpha. So the z alpha is, for the first one, for part A, z alpha is 1.04. So you have to find the alpha value. Sorry, you have to find the confidence level. So how can you find the confidence level? So in this case, this value is 1.04. So now we have to find the corresponding probability. So this is our z-score. So you have to find the corresponding probability. So if you look at the z table for this value, in the z table for this z value 1.04, you will get this probability. That is the confidence interval. That is confidence level. That is 1 minus alpha. And this one is alpha. So here actually you have to find the 1 minus alpha because we have to find confidence level. So confidence level is 1 minus alpha and alpha is the significance level. Okay, so for part A, z alpha is 1.04. So in the z table, look at 1.04 and find the corresponding probability, and that will give you the confidence level, and which is 1 minus alpha. And for the first question, this is 85%. And for part B, the z-score is negative z alpha is equals to negative 2.33. So that's mean here actually we have this value is negative 2.33. So in the z table, if you look at negative 2.33, then you will get 0.01. You will get this value. Then the area of this part will be then 0.99. So that's mean the answer will be 99% confidence interval. Or you can just look at 2.33, then you will directly get 99%. Okay. So for part C, the z-score is 0.58. So for part C, z alpha is equals to 0.58. So now we have to find the alpha value, 1 minus alpha. So 1 minus alpha is 72%. Okay, problem 17 is we are given that the sample size is 50. So an article reported that for a sample of 50 kitchens with gas cooking appliances monitored during a 1 week period, and the sample mean carbon dioxide level was 654.16 ppm. So this is the level of the carbon dioxide, and the sample standard deviation was 164.55. So we are given the sample mean, the sample standard deviation, and the sample size. So the information we know here are the sample size n is equals to 50, the sample mean x bar is equals to 654.16, and the sample standard deviation is 164.55. Okay, so here S is known, but sigma is unknown. Since sigma is unknown, you have to be very careful. You will look at the sample size. If the sample size is large, you will use Z interval. If the sample size is small, you will use T interval. So which interval we should use in this case? N is equal 50. So what do you think? Yes, we should use Z interval, right? Yeah, you're right. Thank you. Because if sample size is greater than equal 40, we'll consider n as large. So we'll use the interval. So in this case, you will use the interval, and the confidence interval formula will be in this case x bar plus minus z alpha over 2. Here this is 95% confidence interval, so it will be then 0.025 s over square root of n. So this is the formula for confidence. This is S. So you have to use this formula. So here you know X bar, you know the sample size N, you know the value of S. You have to just find this value, the critical value, Z 0.025. Okay. Part B is suppose the investigator had made a rough guess of 182 for the value of S before collecting the data. So before collecting data, the investigators they considered the value is 182 for S, the sample standard deviation. What sample size would be necessary to obtain an interval width of 45? So here we have width of the confidence interval, which is 45. And we have the confidence level, which is 95%. So alpha is 0.05. So here alpha is 0.05. What do we have to find here? We have to find the sample size. So what should be the sample size in this case? So the formula for the sample size is n is equal z alpha over 2 times sigma. Here we have s over e square. So this is the formula for the sample size. So n is equals to z alpha over 2 times s over e squared. But what is e here? Do we have the value of e? Anyone? So what is the value of e? E is the margin of error for the confidence interval. So what is the value of e in this case? Yeah, we have s. S is 182. We can find z alpha over 2. So what is the value of e? Anyone? What is the value of e in this case? How can we get the value of e? Yes, 45, but the 45 is not e. 45 is w, right? the width of the confidence interval. But we know the relation between width and the margin of error. So what is the relation between width and margin of error? So E is equals to, yes, you're right. This is W over 2. Thank you. So this is half W. Yeah. Margin of error is the half of the width. So E is here half times W. Now you have to just plug in the numbers and simplify the value for n, and you will always round up. You will always do round up, not round down. So you will always do round up in case of sample size. Okay, so your third quiz is still open on the Blackboard. Open means you can still submit the third quiz, and it will close by this Friday midnight. So if you have not submitted the quiz yet, so you have still chance to submit the quiz. Okay. So number 18, determine the values of the, yes, quiz will close this Friday midnight. You're welcome. So number 18, determine the values of the following quantities. So this, yeah, so we know the degrees of freedom and we have to just find the critical value. So here, so we know the degrees of freedom and we know the alpha value. We have to just find the, so here we have T 0.10 and 14. So 14 is the degrees of freedom and 0.10 is the alpha value. So we know the alpha value, we know 14. So alpha is the probability. So we have to just find the critical value. So what does it mean? That means this is T distribution and we have this area is 0.10. So what is the area of this part? So this part is 0.90, right? Yeah. So we have to just find this value 0.10, 14. So we have to find this one. So you can use t-table to find this one, or you can also use calculator. So I'm showing you how to use t-table to find the critical value in this case. So let me pull up the table. Okay, so here is the, you can use this t-table or you can use the t-table provided in your textbook or on the web assign. So here we have the degrees of freedom. So the degrees of freedom is 14 and the alpha value is 0. So here we have the critical value for one tail or two tails. Yes, for two tails, if t 0.50, for one tail this is 0.5. So that's meaning the probability is 0.5. So if the tail is 0.5, so then that will be the critical value. Okay, so what is the probability in this case? So in our case, the alpha value is, okay, let me check what was the alpha value. So in this case, the alpha value was 0.10 and the degrees of freedom was 14. So the alpha was 0.10 and the degrees of freedom was 14. So if you look at the table, then you can see degrees of freedom 40, 14, and alpha is 0.10. So here, this is the alpha value. So this value is the alpha value here. So can you see the T table? So if you look at here, then you can see the alpha is 0.10. So this is for one tail because we are just finding the critical value for the upper tail. So that's mean this is 0.10 and degrees of freedom is 14. So the value is 1.345. So here you can see the value is 1.345. So now go back to the problem. Okay, so here you can see the T value is 1.345. And similarly, you can find the T for this one. Alpha is 0.05 and degrees of freedom is 14. So go back to the T table. So here you can see the degrees of freedom is 14 here. So this is 14. So this is the degrees of freedom. And the alpha is 0.05. So this is 0.05. So alpha is 0.05, degrees of freedom is 14. So the critical value is 1.761. So if we go back to the problem, then you will see the critical value is 1.761. Yes, the critical value is 1.761. And similarly, you can find the critical value for this one, these degrees of freedom. So the degrees of freedom is 23 here and alpha is 0.05. So if you look at the alpha value and the degrees of freedom, the corresponding T value will be 1.714. And similarly for this one, the degrees of freedom. Okay, so if you do not have the degrees of freedom in the table, for example, if you have a very large degrees of freedom and if you do not have that one in the table, then that will be actually the probability. If you increase the degrees of freedom, the critical value will be actually will increase if you increase the degrees of freedom for the same alpha value. So if you increase the degrees of freedom, the critical value will increase. No, if you sorry, if you increase the degrees of freedom, then yeah, the critical value will decrease. So you can just find the approximate critical value if you do not have the degrees of freedom in the table. Yeah. Okay, number 19, determine the T critical value for a two-sided confidence interval. So this is for two-sided confidence interval. So you have to find the critical value. So you can just look at to find the critical value, you can just look at the table in this case also. So here the confidence level alpha is, so here the confidence level on minus alpha is 0.95. So alpha is 0.05. So the confidence interval determines the T critical value for a two-sided confidence interval. It is of the following situations. So you have to just find the critical value. So that's mean T alpha over 2 and degrees of freedom is 5 for the first one. So that's mean you have to just find 0.055. Sorry, 0.05 over 2, 5. So that's mean 0.025 and this is 5. So you have to look at this probability or this alpha value in the table and degrees of freedom 5. And for this one, the alpha is same, alpha is 0.05, the degrees of freedom is 20. So you have um, larger degrees of freedom. So in this case, you have to just find t 0.025 and degrees of freedom is 20. So in this case, the alpha is different. The alpha is 0.01. So in this case, the alpha is 0.01 and degrees of freedom is 20. So you have to just find the critical value. So for part C, you have to find alpha over 2 df. So that's mean you have to find 0.01 divided by 2 and df is 20. So you have to find 0.005 and this is 20. So you have to just find this one, this critical value. Okay, similarly, you have to find the critical value for each of them. And number 20 is a sample of 15. Here the sample size is 15. Joint specimens of a particular type gave a sample mean proportional limit stress of 8.48. The sample mean proportional limit stress. So we are given the sample mean proportional limit stress and which is 8.48 MPa megapascal and a sample standard deviation of 0.71. So we are given the sample mean is 8.48 and the sample standard deviation S is 0.71. So here what information we have here, the information are N is equals to 15, S is 0.71 and X bar is 8.48. So we have this information. So now the first one is calculate and interpret a 95% lower confidence bound for the true average proportional limit stress of all such joints. So you have to just find the average proportional limit stress. Okay, so here sigma is not known, right? So sigma is not known. If sigma is not known, then you have to look at the sample size. If the sample size is large, you do not need any other assumption. But if the sample size is not large, we need to have some assumptions, right? So the first you need to find the confidence bound for the true average proportional limit. So that's means the confidence bound for mu, and we have to find the lower confidence bound. So that's means mu greater than, we have to find x bar minus t or z, whatever it is, s over square root of n. So what type of interval we should use in this case? Should we use z interval or t interval in this case? Yes, we have to use t interval in this case, right? So that's mean it will be t alpha, right? Because this is one-sided, just lower limit, x bar minus t alpha, and degrees of freedom is 15 minus 1, so that's been 14. So the formula will be for this one, x bar minus t alpha 14 times s over s square root of n. Okay, so now we know x bar, we know s, we know n. So you have to just find the critical value, and you already know how to find the critical value for t distribution, from t distribution. So now the second part of the question is interpret this bound. So how can we interpret this bound? We are 95% confidence we can say that the value of the true mean, since this is the lower bound, so we are 95% confidence that the value of the true mean proportional limit stress will be greater than this value, right? And we are 95% confident about this. So how about this one? We can say that the value of the true mean proportional stress limit is also joints created around this value. No, this is not true, because we are confident that the true mean will be above this value, right? Because this is the lower limit of the true mean. So we expect that the true mean will be greater than that value. not less than, not around. We expect that the true mean is larger than the lower limit. Okay, the third part of this question is what, if any, assumptions did you make about the distribution of the proportional limit stress? So that's mean they are asking whether you made any assumption about the population distribution. So do we need any assumption for the population distribution in this case? What do you think? Do we need any assumption? Yes. The assumption is normal distribution. Yeah, you're right. Because when the sample size is small, so and sigma is unknown, so we need to have an assumption. The assumption should be the population distribution is normal. Yeah. Okay, so part B is calculate and interpret a 95% lower prediction bound. So now we have to construct the prediction bound for proportional limit stress of a single joint of this type. So the prediction interval. So lower prediction interval means x bar. So the lower prediction interval means x bar minus t alpha degrees of freedom is 14 times square root of times s times square root of 1 plus 1 over n. So the difference is here. So the difference is here, instead of square root of 1 over n, we have square root of 1 plus 1 over n, because this is the prediction interval or prediction bound. This is the interval for a single value, not for the mean. So when we construct the interval for mean, that called confidence interval. And when we construct the prediction interval for a single value, that called the prediction interval. And the difference is, for confidence interval, the formula is x bar minus t alpha 14 s over square root of n. But in this case, the formula is x bar minus t alpha 14 times s times square root of 1 plus 1 over n. So that is the difference. And the prediction interval will be wider than the, if the confidence level or prediction level are same. If the alpha is same, then the prediction interval will be wider than the confidence interval. Okay, so now you have to interpret this bound. So first one is, if this bound is calculated for sample after sample, in the long run, 95% of the bounds will provide a higher bound for the corresponding future values. So no, this is not the higher bound, because we are constructing the lower prediction bound. So this is the lower bound actually. So how about this part? If this bound is calculated after the, in long run, 95% of these bounds will be created around the, not around the. It should be, the future value should be above this value, because this is the lower bound. So the 95% bound will provide a lower bound for the corresponding. Yes, it will provide the lower bound of the corresponding future values of the proportional limit stress of a single joint of this type. Okay, so the next problem is 21. An article gave the following summary information for fracture strength of n is equals to the sample size, n is equals to 169, which is large sample, and x bar is 79.62, s is 3.82. So here s is known, the sigma is unknown, and since this is the large sample, so you can use z interval. So calculate two-sided confidence interval for the average fracture strength using a confidence level of 95%. So you have to use z interval in this case, because we, the sample size is large here, so we do not need to use t interval in this case. You can use z interval. So the formula will be then x bar plus minus z alpha over 2 s over square root of n. So this is the formula for the confidence interval. So now the question is, does it appear that the true average fracture strength has been precisely estimated? So if you look at the confidence limit, the lower limit is 79.04 and the upper limit is 80.20. So that's mean the width of the confidence interval is very small. So that's mean the confidence interval is very narrow. So it is very precise. So that's mean the answer will be yes. This is a very narrow interval. So that's mean we calculated the true average fracture strength precisely. So part B, suppose the investigators had believed a prior that the population standard deviation was about 5 MPa. The population standard deviation, that means sigma. Sigma was 5. Based on this assumption, how large a sample would have been required to estimate mu to within 0.5 MPa with 95% confidence. So alpha is here 0.05. So since we have population standard deviation, so we do not need to use t interval. You can use z interval in this case. And we have large sample, right? So you can use z interval in this case. So now we have to find the sample size. To find the sample size, the formula is n is equal z alpha over 2 times sigma over e square. So now the question is, we know sigma, that's fine. So what is that? We know alpha, so we can calculate z alpha over 2. So what is the value of e here? So what is the value of margin of error? So what is the margin of error in this case? Yes, margin of error is 0.5. Z alpha over 2 times, yeah, that's the formula for the margin of error. That's correct. Yeah. But here the margin of error is 0.5. Yeah, but one of you say asked whether it should be 0.5 over 2. Yeah, no, it shouldn't be 0.5 over 2 because if you look at the question, it says that mu should be within 0.5. So that's mean the mu should be, we have to estimate the mu within 0.5. So the lower limit will be mu minus 5 and upper limit will be mu plus 5. So that is the question actually. So this is actually margin of error, not the width. Because if you calculate the width, then it will be mu plus 5 minus mu plus 5. So width is 10 here actually. This is cancelled out, width is 10. So this is W. But this is actually E. So here E is 5, not 5. Sorry, 0.5. I'm sorry. This is 0.5. This is 0.5. Yeah, this is 0.10. So mu is zero point 0.5, not 0.5 over 2. Okay. Is it clear? Why mu is, sorry, why E is zero point 0.5, not 0.5 over 2? Okay, that's good. So the next question is determine the value of following quantities. So we have to determine the value. This is chi-square. This is from chi-square distribution. So we have here the alpha value, and so this is chi-square distribution. So we have chi-square 0.05, and this is 10. So to find the critical value from chi-square distribution and to find the probability, we need actually the degrees of freedom and the alpha value. So this is the critical value from chi-square distribution. So the degrees of freedom is 10 here, and the alpha value is 0.05. So we have to calculate the chi-square value. So what does it mean? That's actually mean the chi-square distribution actually look like this. This is skewed distribution. So this is chi-square 0.05 comma 10. So we have to find this one, and this probability is 0.05. So now if we look at the chi-square table, then it will give us the critical value. So find the chi-square table. Chi-square table. Okay, so here is the chi-square critical value. So we have the degrees of freedom. The degrees of freedom was 10, and the alpha value was 0.05. So for 0.05, alpha value 0.05 and degrees of freedom 10. So here this is the degrees of freedom, which is 10. So this is the degrees of freedom, which is 10, and the alpha is 0.05. So the chi-square value is here, 18.307. So for the first one, the chi-square value is 18.317, 307, or 18.31. And the second one, chi-square 0.5, the degrees of freedom is 30. So chi-square 0.5, and the degrees of freedom is 30. So the degrees of freedom is 30 and chi-square 0.05. So here we have 0.05, but we do not have the degrees of freedom 30. So it should be actually more than 31. So if you increase the degrees of freedom, the critical value will increase. So it will be actually greater than 31. If you cannot find the exact value, you can just say greater than 31 point. But in the table provided on your textbook, you will have also like more degrees of freedom. Okay, so if you want to find chi-square, for example, if you want to find chi-square 0.001, degrees of freedom is 15. Then degrees of freedom is 15 here, and 0.001 is here. So then it will be this one, 37.697. 37.697. Similarly, if we want to find chi-square 0.01 and 11. So this is degrees of freedom 11, and this is 0.01. So the chi-square value will be then 24.725. And similarly, if we have, for example, if we know the degrees of freedom and if we know the chi-square value, if we want to find the probability, for example, if the degrees of freedom is chi-square 11, and which is the chi-square value is, for example, it is 29.141. So we want to find the probability. So how can we find the probability? So here this is 11, and the critical value is 29.141. So sorry, for example, consider this is 14, not 11. This is 14. So the degrees of freedom is 14. Now the critical value is 29.141. So here 29.141. The corresponding probability is 0.01. So the probability will be then 0.01. Do you have any question? Well, okay, so similarly, we can find the chi-square value for this one. You can find this. You can find any chi-square value. So here the degrees of freedom is 30, 30, and here this is the corresponding probability. So from the table, you can find this one, or you can also use the calculator to find the critical value for chi-square distribution. Okay, number 23 is the amount of lateral expansion was determined for a sample of n is equals to 8. Here the sample size is 8 and the sample standard deviation S is 2.86. So the sample size n is equal 8 and S is equal to 2.86. Alpha is 0.05. So we have to construct the confidence interval for sigma square and sigma. The confidence interval for sigma square is, so it is provided on your note, on the lecture note. So okay, so I should write on a fresh page the confidence interval for sigma square. So the confidence interval for sigma square is n minus 1 is a square divided by chi-square alpha over 2 n minus 1. And the upper limit is, this is the lower limit. So the upper limit is n minus 1 s square divided by chi-square 1 minus alpha over 2 and n minus 1. N minus 1 is the degrees of freedom. So you will be given the value of S, you know the sample size, you know alpha value. So you have to just find chi-square alpha over 2 with degrees of freedom n minus 1. So you can forget this value from the table. So to construct the confidence interval for sigma, just take the square root of the previous interval. So that's been a square root of n minus 1 s square divided by chi-square alpha over 2 n minus 1 and square root of n minus 1 is square chi-square 1 minus alpha over 2 comma n minus 1. Okay, so the difference between the lower limit and upper limit is the alpha value. So this is alpha over 2, this is 1 minus alpha over 2. And this interval for sigma, and this is for sigma square. So you will use that formula to construct the confidence interval for sigma and sigma square. So this is the confidence interval for sigma square. So if you take the square root of this one, you will get the confidence interval for sigma. So if you take the square root of this one, you will get the confidence interval for the upper limit for sigma. Okay, so number 24, determine the following. The 95th percentile of the chi-square distribution with nu is equals to, nu means the degrees of freedom is 15. So 95th percentile. So what does it mean by 95th percentile? So this is chi-square distribution. So it will be like this. So now we have to find the chi-square value. So that 95th percentile. So that's mean this is 95% and this is 5%. So that's when we have to find 0.05 and nu is 15. So you have to actually find this value. And you already know how to find this value from the chi-square table. So you know alpha, which is 0.05, and the degrees of freedom is 15. Similarly, for part B, the 5th percentile of the chi-square distribution. So what is the 5th percentile? 5th percentile means this value is 0.05 and this value is 0.95. So that's mean we have to find chi-square 0.95, and the degrees of freedom is 15. So you have to look at this number. Similarly, part C, we are given the confidence interval where chi-square is the squared RB with nu is equals to 23. So we have to find the confidence level. So what is the confidence level here? So we have to find the probability between this number and this number. So you can use calculator, directly use calculator to find this probability, or what you can do, you can look at this number, you will get one probability, and you can look at this number, you will get another probability. So you will subtract, you will take the difference of these two probability, and that will give us 0.95. And for this one, you will find the probability for this value, and you will find the probability for this one, and you will add them together. And that will give us the probability for this one. So for example, this is chi-square less than 18.493. So, and the degrees of freedom is 30. So you have to look at this number and this degrees of freedom. That will give us one probability. So you will take that probability, and then you will consider this chi-square value and look at this number. That will give us another probability, and maybe uh, actually it depends on the table. So sometimes if you just look at this number, that, for example, if you look at, suppose if 18 is, okay, so it depends on the table, which table you are using. So if you look at this number and the degrees of freedom, sometimes you will get this area and sometimes you will get this area. So if your table, if your chi-square is this type, that's mean chi-square alpha df. If the chi-square table give you this type of probability, then if you look at this number, you will get the probability on the right. But if you have this type of table, chi-square less than chi-square alpha df, then it will give you the area on the left side. If you look at this number and the degrees of freedom, it will give you the area on the left side. Okay, so here we have probability of chi-square less than. So that's when we are looking for the area on the left side. So if your table give you the area on the right side, then you will just subtract that area from 1 to get the area on the left side. And similarly here, if your table give you the probability on the right side, you will just look at this number and consider that probability, and you will add these two probability together, because we have or here, probability of this one or this one. That's mean you will add these two probability, and the total probability will be 0.01. So the answer for this one is 0.01. The probability is 0.1. Okay, so that's all for today. If you have any question, you can ask me. So, and for attendance, you should type present. Do you have any question?